Hey guys, happy Friday. Today is December the 4th. It is the 4th day of Number Corner for December, and it's Friday. It's going to be a great day. We don't need to update our calendar grid today because we looked at our first 4 markers yesterday, and so that's already been updated. But today, you may notice we are doing a problem string. So go ahead and get out your Number Corner journals. Open it up to your problem string workspace and place today's date at the very top of the page. And you can even label it problem string 11. While you're doing that, I do want to remind you, when we did our problem string just the other day, earlier this week, we focused on addition and subtraction, and you guys were able to determine when it was more efficient to take away for subtraction versus when it was more efficient to find the difference between the two numbers. And if you don't remember, I will remind you, it was more efficient to take away when you were taking away a smaller number. But when the numbers were very close together, it made sense to find the difference between them. Okay, and you could count up from the smaller number to the bigger number, or count backwards from the bigger number to the smaller number. And either way it goes, you would get the same answer. So today, as we work through our problem string, think about some of those strategies. But as we continue to go through some of the questions, I hope that you will find another strategy useful. I will tell you, the purpose of going through so many different strategies for addition, subtraction, multiplication, division, whatever it may be, is so that you guys have strategies in your toolbox to fall back on when you're solving different problems. Also because different strategies in different situations make more sense than using other strategies. So my job is to help you understand those strategies so that you can figure out when it's best or most efficient to use them. Okay? All right. I always like to start off with the context because context helps you solve word problems. So the context for today is I have a friend named Tony who works in a soup kitchen or works at a soup kitchen. And if you don't know, a soup kitchen is just a place where people who struggle to get food can go to be fed. Okay? So when they're serving their food, they try to reserve half for the morning and then save half for the afternoon because they only have a certain amount of food to serve. Okay, so that's our context. Hopefully by now your book is open, you're ready, and we are going to get started. First problem. Says Tony, my friend who works at the soup kitchen, has been keeping track of how much food has been served at breakfast and lunch for the past month. On the first Saturday, they started with 95 pounds of food. After serving breakfast, they still had 48 pounds of food. How much food did they serve for breakfast? So go ahead, work it out. Pause this video if you need to. All right, so what'd you get? All right, so did you find the difference? Did you take away 48 or did you find the difference? Probably found the difference. So, let me show you what that might look like on a number line. And maybe I've zoomed in too much, so here we go. If you start at 48, how can you get to 95? What might you add to the number 48? Good, you could add 2 because you want to get to a friendly number. So 2 would get me to 50. And then what do I need to add from 50 to get to 95? Good, I would just need to add 45. So if I have 2 plus 50, so here's my 50. Oop, excuse me, that's not 50. I went from 50 to the number 95. So if I, here's my 45, and here's my 2. What is the difference? Good, it is 47. And I want to show you, something. And I'm going to use the same number line to show you, but I'm going to use a different color. Okay, I'm going to choose yellow. So I'm at 48. I could go to 49 before I go to 50. And maybe if I'm doing this in my head, and I'm going to go past 95, 96, 97, because the distance between 49 and 96 is the same as 48, 95, because I just shifted it, each number over 1, so the distance remains the same. Just like the distance between 50 and 97 still has a difference of 47. Now, the reason you might find this useful is because in your head, if you know that if I keep a constant difference, if I add 2 to one number, so in this case I went from 48 to 50, and I add 2 to the next number, my distance between those things stays the same. Imagine yourself in a race, and let's say you're racing a younger sibling and you give them 2 steps. You want them to be 2 steps ahead of you, right? Just to give them a little jump start to hopefully beat you, which we know they probably won't. And so if you were to take 2 steps forward, what does your sibling have to also do to maintain that same distance between you guys that you started off with? Take another 2 steps. So this is kind of like the same thing, and we call it constant difference, okay? So in this case, you guys added 2 to get to a friendly number, which was 50, and then you added your 45, which is 47. Or maybe you thought in your head, well, if I go to 50, I know 47 would be 97, and so it's the same thing because I kept my distance the same, okay? So if that doesn't make that much sense to you quite yet, it's okay. We're going to keep working on it, okay? Let's look at the next problem. On the next Saturday, they started with 97 pounds of food after serving breakfast, and they still had 50 pounds of food. How much food did they serve for breakfast? Look at that. We just kind of worked through this problem. So I'm just going to draw that number line out for us again. You don't even need to rework it because we just did it. Here's my 95. And, I should say here's 97. Here's 97. Here was my 48, but now I'm at 50. Okay, and it's really easy to find the difference because just add 47 still. You'll see that? So if you didn't get it before, hopefully now you are going to get it as we go through this next problem. So 95 minus 48 is 47. 97 minus 50 is still 47, and the difference between these two problems is I added 2 to both numbers. Added 2. Let's see what happens with the third problem. On the next Saturday, they started with 96 pounds of food, and then they still had 49 pounds of food. So how much did they serve now? I'm going to change the color. I'm going to use my very same number line. Here will be my 96. And here will be my 49. And so 49 to 96, I could still do my 1. And then I still would have 46 to go, which still gives me a running total of 47. Same thing. 1 plus 46 is 47. Same difference. I just keep shifting my numbers over either way. In this case, I'm shifting it over 1. So I'm taking away 1 from each number. We starting to get it? Is this starting to make more sense? Well, let's see what's going to happen with this next problem. Saturday, they started with 100 pounds of food. After serving breakfast, they still had 53 pounds of food. How much food did they serve for breakfast? Work it out. See if you can use what we already know to figure it out. Okay, are you seeing the connection? How is, that line is just way too crazy looking for me. Okay, how are The numbers 153 related to 96 and 49. Or even we could go back to our original problem and we can say 95 and 48. But let's stick with 96 and 49 since we just solved 96 and 49 and we got 47. How is that related? If I were to put 49 here, what would I need to add to 49 to give me 53? Right, it's a difference of 4. So I added 4 to this number. Well, then let's look at the number 96. And we need to go to 100. What is the difference between 96 and 100? Right, it is also 4. So I shifted both numbers 4. I shifted both numbers 4, which means I essentially should get the same answer. So 100 minus 53 is what? It is still 47. 47 is our magic number. And if I were to show you, if I were to show 49 to 96 on the same number line, here's my 47 here. Okay? So the big idea here is that you can add or subtract a number to both numbers to make an easier problem to solve or to get to a friendly number. So for 49, it would be really good for me to get to 50, so I could add 1 to both numbers, which would then be 97 minus 50, which is what we solved here. Because if I do that, it makes it so much easier to solve when I'm at a multiple of 5 or a multiple of 10. Okay, let's keep going. Let's see what our next problems have in store for us today. Oh, no context. It just says 171 minus 86. I want you guys to choose a strategy to use to solve this problem. Great. So what answer did you get? You guys found the difference between the numbers? So how'd you do it? Okay, maybe add 4 to give you 90, right? And then you could add 10 to give you 100. This is just one way that it could be done, right? And then from 100, we could just add our 71. So where's our answer? It's up here. What is our answer? 71 plus 10 is 81, plus 4 is 85. If you got 85 as your answer, great job. See if I use a different strategy. All right. Well, let's look at the next problem. 175 minus 90. Work it out. Right, did you see a connection between the two problems? It looks like we shifted 4 from 86 and we shifted 4 from 175, which means the difference between those two numbers remains the same. So what should our answer be? It should be 85. It's called constant difference. If you add a number to both numbers or subtract a number from both numbers, your difference is going to remain the same. The purpose of doing that is so that you can get to an easier number to work with. So in this case, we added 4 to 86. So if we add 4 to 86, we have to add 4 to 171 to keep the difference or the distance the same. And in this case, it was 85. Now when you do this, it makes it really easy to add or subtract in your head. Really subtract when you're talking about constant difference, to subtract in your head. Let's look at the last problem. 167 minus 82. Work that one out. See if you can see the connection. Right, are you guys noticing that it shifted the other way instead of adding numbers? Yeah, so if this were 171, which was our original problem for this string, this is a difference of 4. And if I were to put 86 here, and between 82 and 86 is a difference of 4. So we knew that 86 and 171 was 85, which means what? What is 167 minus 82? It is also 85. What we just did is we used the constant difference strategy. Constant difference means just that. If you were to add some to both numbers or take away some from both numbers, the difference between them stays the same. And just as a way for me to see that you guys really understand what's happening with the constant difference strategy, I have 2 problems that I want you to solve so that you can show me how you might use the constant difference strategy to solve the problem. So you can use the whiteboard app from the Math Learning Center. You can write it down on a piece of paper, screenshot it, send it to your teacher, whatever you need to do to show that you understand is what I need for you to do. Okay, so here are the 2 problems that I would love for you to solve. The first one is 279 minus 24. 279 minus 24. And the second problem that I would like for you to solve is 106 minus 61. I want to know how you might use the constant difference strategy to solve these 2 problems. So work it out, share it with your teacher. If you need to rewind this video to see it again, please do so. But remember, constant difference means the distance between the numbers remains unchanged. So if you add something to one number, you got to add that same thing to the other number. If you take something from a number, you have to take that same thing from the other number. Good luck, and I can't wait to see and hear about how you're doing with this. Have a good afternoon.